So in this video, we'll be going over the ranking task example where we have blocks on different inclines. And what we're asked to do is to rank their gravitational potential energies. So let's start off by reminding ourselves what the gravitational potential energy is. And so that's equal to mgh, where h is based off of some baseline value. And so that's going to be our first task. We need to start by defining where is the potential energy 0. So what's our baseline value? And what we're going to want to do, since we are asked to compare different situations, what we want to do is we want to choose them all to have the same 0 point for their potential energies. And what I'm going to choose, and what's the easiest choice, is to choose the bottom of the ramp, so on the ground, to be the h equals 0 line, where h equals 0 means that the potential energy is equal to 0. So for all of these, I'm going to choose h equal to 0. In this way, we can compare what the magnitude of the potential energy that we find for each. And that way we can rank them based off of that value, since they all have the same relative 0 point. So now that we have an expression for the potential energy and we have our 0 point, we can just go ahead and rank them. We can solve for their potential energies. So I'm going to approximate g to be 10 meters per second squared. You can use 9.8. It's just I want to be able to solve this in my head. So we have, for the first one, we have a mass of 10 kilograms. So we have 10 times 10 for the acceleration due to gravity times a height of 1 meter for the block. So that's equal to 100. And what are the units of potential energy again? The units of potential energy are joules. And if you ever forget, you can always just go based off of the equation. A joule must be equal to a kilogram times meters squared all over second squared. Just going off of what these base units are, where mass is a kilogram, the acceleration due to gravity is meters per second squared, and then height is in meters, giving us kilogram meter squared per second squared. So continuing on, we have a mass of 10 kilograms again. We have, again, it's a height of 1 meter. The slope is different, but the height of the block, which is all that matters for potential energy, is still 1 meter. So those two are equal. So they look different, but they have the same potential energy because they are at the same height above our 0 point. Coming down here to C, we have 5 kilograms times 10 meters per second squared times 1/2, which is equal to 25. Here we've got 1 kilogram times 10 times 2 for the height. Again, we go in off of the height here, and that's equal to 20. Then for this one, we have 1 kilogram times 10 meters per second squared times 0.75 meters for the height, which is just 3/4. And that's equal to 15/2, or 7.5. And then rounding off for F, we have 15 kilograms times 10 meters per second squared times 0.75 meters again, but that is 3/4. And that comes out to 112.5. So now that we calculated all the potential energies, we can go ahead and rank them. So starting with the smallest, we have E. Next up, we have D, then C. A and B are both equal to 100. So those are the same, A and B. And then F was the greatest potential energy. And so just to wrap up, how did we do this? We started by choosing where our potential energy, gravitational potential energy, is equal to 0. So we can compare them all. Then we calculate each potential energy, gravitational potential energy, to compare. Where the gravitational potential energy, again, is equal to m times g, the mass times the acceleration due to gravity, times the height, where the height is in reference to our 0 point for potential energy.